All right, here's a helpful video going over some problems from chapter 6. We're going to do question 11 and 21 from 6.1. So let's go to 6.1 and let's look at question number 11. We're probably going to try to utilize StatCrunch if possible, and then if that doesn't work, we will kind of write it out. But there it is. It says one question from a survey was, how many credit cards do you currently have? The results of the survey are provided. All right, let's take a look at the survey results. Okay, it's a lot. Determine the mean number of credit cards based on the raw data. So the mean would just simply be to add them all up and divide by the total number. And this is better suited for a computer. So we're going to use our StatCrunch here. We have all the data. And here we're going to go to Stat, Calculate. Actually, let's see. Summary Stats will probably do it. Column, 1 var, and it's going to give us a lot of stuff. We just want the mean, but we got more than just the mean, okay? We got 3.07, and they want us to enter the data in, type an integer or a decimal, and do not round. Well, it's interesting how they said do not round, because well, it's okay. 3.07 is not much. So let's try that. Alright. That didn't seem too bad at all. Determine the standard deviation number of credit cards based on the raw data. Now, I think I did do the standard deviation as well. There it is there. Standard deviation. Now, the problem is that this is a sample, and they probably want the sample standard deviation. So what I'm going to do is I have to make sure that my calculations is the sample standard deviation. So I have to do the unadjusted deviation as well. We're going to select column, unadjusted, and this time we get 1.83, and they want 3 places, so 1.834. Now, had I used this one, I would have gotten 1.843 or 8.844. But I think they want the unadjusted one. So let's do let's pull that back up again. So we're going to type in 1.834. Let's check. Okay, they said that's not correct. Okay, so they did not want the unadjusted one. They wanted the... Okay, so unadjusted would have been the population. So let's do 1.844. All right, and now finally determine a probability distribution for the random variable x, the number of credit cards issued, all right, so here we're about to calculate the probability distribution. We basically need to know how many ones there were, and then we're going to divide that by the total. I'm curious to know if StatCrunch can handle this. So we're gonna look at some charts that maybe we can allow StatCrunch to try to do. Um, and let's do the relative frequency compute. And let's make sure that that works. Three. This looks really good. This looks really good. All right, so this should probably be it. Let's check. For 1, we got 0.14. For 2, we got 0.3. For 3, we got 0.3. For 4, we're getting 0.11. For 5, we're getting 0.07. For 6, 0.01. 7.02. 8.02. 9.02. And for 10.01, let's see if it likes it. It did. And that was the end of that question. There was another question on 2.1, or number 21. All right. So it says compute the theoretical mean of the random variable x for the given probability distribution. And we're probably just going to use StatCrunch again. So here we have two different data tables, the table for 25 games, 50 games. Also, we're getting it. So it looks like for the first part of this question, they want us to use the probability distribution. Let's open it in Excel. So all we're looking to do is to multiply those two together. So it's going to be this times this. A2 times B2. And we're going to do that all the way down. And now all we're going to do now is take the sum of them, the sum of that column. Nope, that copied it, but we're going to take the sum. So we do equals the sum of this. And we got 1.607. 1.607 is good. It's just too bad we weren't able to do it using StatCrunch, though. I'll probably have to get back to that. And now here's the other question. Compute the theoretical standard deviation of the random variable x for the given probability distribution. It seems to me that we definitely need to use technology for this. The formula will be way too complicated, is what I'm thinking. Well, the data is not, is it binned? I guess this could work. Let me see. No, it's not. Yeah, it's not gonna work. Um, let's see. Well, if we use the graphing calculator, we could, it would have given it to us. So we'll probably go back into StatCrunch and maybe make a custom graph and see what that does. So we will go to Stats, Calculator, and then Custom. We'll select X and we'll select P of X, hit Compute, and here we have the mean, which we knew was that, but this time they're giving us the standard deviation. And if we round it to 2 places, it's going to be 1.16. Let's make sure that that's what they wanted 2 places to that. Oh, they want 3 places. Okay. Oh, we can give 3 places. So it would actually be 1.56. 1.56 should be good. 1.156. And we got it. This time they're saying approximate the mean of the random variable x based on the simulation of 25 games. And this is a different type of question now. Here, I'm assuming this is um, the simulated, 25 game simulation, number of hits. And then for 50, it's here. Yeah, I mean, we'll have to just, I mean, when they say approximate, we basically have to go through the same cycle. So let's just do that real quick. Let's just go through it. So what we did was we created a So we have this table now. Should be 25 of them all together. 11 and 11 plus 3 is 25. We know how many in each one, and we even have the relative frequency. And then now we're going to get the mean. So let's write this out. We have 0, let's move over here. So we got 0, 1, 2, 3, and then in column 4 we have 0.16, 0.28, 0.44, 0.12. And then we're going to do that custom stat calculator thing again. But this time we're going to choose those two variables. So variable 3 and variable 4, compute. And we're getting 1.52 for that mean. And we're getting, for the deviation, I think I still have it up. They want 3 places, so 8, 9, 9, but then that goes to 0, so 0.9 is going to be the right answer. Let's round that off one more time. Yeah, I mean, it's just 0.899977. I don't see why that's not going to work. Maybe, I mean, wait, approximate the standard deviation of the random variable. .91. And now for 50 games. Alright, we need to create that frequency table thingy. And what we'll do is go over here, we'll do 0, 1, 2, 3, 4, 5. And over here, 0.18, 0.26, 0.36. 0, 1. Oh, there's no 4. Okay, let's take a 4 out. And there's no 4. If there's no 4, there's no 4. And we got 0.02. And now from here, let's see, let's go to the calculator custom, and we'll do var 3 and 4. There was no 4, but there is 5. We got 1.62 for the mean and 1.0 0.93 for the other thing. So first let's try 1.62. Oh man, did I just close that? I did not mean to. And then 1.093. Yeah, they're not calculating the right formula. It's off a little bit, and I think it has something to do with the population mean versus the sample mean there. Or another thing it could be, yeah, it's just not. It's gonna just be off. We'll just hit it 3 times. Yeah, it's gonna be off a little bit every time. And now you're gonna compare the theoretical means, which is the ones up here, to those estimated means from the generation, from the the experiment, the generated means. We'll compare them and answer some questions. So for the simulation of 25 games, the mean is well, let's see. 1.52 and if you compare that to the theoretical mean, it's so about the same. 0.98. I would say again about the same. For the simulation though, 1.62. Now we're really about the same. About the same. So I'm gonna go with seemingly unrelated. And the other ones are really about the same. Well, let's check the deviation one more time. 1.156, 1.62. Maybe we can go about the same for each one. Yeah, about the same for each one. I'm going to go with the law of large numbers.